Okay, ji, Assalamu alaikum. This is A2 Trigonometry lecture number 1. We are starting off with identities today. Let's just start off with revision of what we have done in AS. We know that sine square theta plus cos square theta is equal to 1. This sine square theta plus cos square theta can be changed to a different identity as well, which means this can be changed to cos square theta, which can be written as 1 minus sine square theta plus as well as it can be written as sine square theta is equal to what? 1 minus cos square theta. So this was what you have studied in your AS. Apart from this, you have also studied tan theta, which is sine theta upon cos theta. And with respect to these identities, you should be well aware that these identities were applied with different identities, such as your basic O-level identities, which are a plus b whole square, which is known as a square plus 2ab plus b square, whereas a minus b whole square is also known as a square minus 2ab plus b square. Your a square minus b square is written as a plus b and a minus b. So these are your O-level identities. You should be well aware that with respect to your AS identities and your O-level identities, your A2 identities are then mixed and merged. So your A2 identities, now what actually are your identities? That means you can substitute any of the value in place of the other value. Like for suppose if I say that sine square theta, if it's written, we can easily write down 1 minus cos square theta instead of sine square theta. With cos square theta, if it is written in the question, we can write down 1 minus sine square theta. So identity is basically replacing the identity with the best of the identity, which is exactly or similar to the identity that is given. Now, let's say that your first A2 identity that you should be well aware is that when you have a sine theta that is reciprocal of sine theta, your sine theta reciprocal of sine theta. That means if you have 1 upon sine theta, this is known as your cosec theta. 1 upon sine theta can be written as cosec theta. Whereas you should be well aware that your 1 upon cos theta, 1 upon cos theta. That means reciprocal of cos theta is 1 upon cos theta is identical to sec theta, is identical to sec theta. Similarly, we have cot theta. Your cot theta is basically reciprocal of what? 1 upon tan theta, which can be written as 1 upon sine upon cos, and we can eventually write this thing as cos theta upon sine theta. So that means cot theta can be written as 1 upon tan theta, or it can be written as cos theta upon sine theta. Then we have is 1 plus cot square theta, which is written as cosec square theta. We have 1 plus tan square theta, which is written as sec square theta. So 1 plus cot square theta is known as your cosec square theta, and 1 plus tan square theta is identical to what? Sec square theta. With respect to this, we also have identities which are reflection of compound. That means when two different values are given, when compound angle identities are there. So we'll be writing down compound angle identities. Now, what are compound angle identities? For suppose, let's say we have sine A plus B. Now, in A plus B, what we can have is in the question, for suppose A is theta and B is 30. So, or this is 30 and this can be written as theta. So, what we can replace this as with, we can replace this thing with the identity of sine A cos B plus cos A sine B. Similarly, if with the same compound angle identity we have sine A minus B. So this can be written as sine A cos B minus cos A sine B. That means the identity is exactly the same, but the sign changes everything. So if it's plus in the given question, we'll write down as plus. If it is negative in the given question, we'll write down as negative. The other identity that we have is cos A plus B. So cos A plus B is written as cos A cos B minus sine A sine B. And if it is given as cos A minus B, if it is written as A minus B, we write this thing down as cos A cos B. Since it is negative in the question, we have positive here. It should be sine A sine B. Similarly, if we have 10 A plus B. So 10A plus B is basically written as 10A plus 10B upon 1 minus 10A 10B. And if it is given as 10A minus B, then it will be written as same as the equations, but the signs will be changed since it is minus. So 10A minus 10B upon 1 plus 10A 10B. So compound angle identities, to make sure that these identities you know in better way. So we remember them as that sine A plus sine B. So sine A cos B, then we have cos A sine B. Since it is plus, we write down plus. If it is sine A minus B, write down sine A cos B. Since it is minus, we write down minus cos A and sine B. If it is cos A plus B, so it is cos A cos B. Since there is positive here, we write down negative. So this should be sine A sine B. Cos A minus B, since this is negative, we have positive here, but cos A cos B sine A sine B. If it is 10A plus B, 10A 10B, 1 minus 10A 10B. But obviously, if it is plus, we write down plus here, but the sign is changed in the denominator. If it is A minus B, 10A minus, obviously it will be 10B. Since we have minus here, minus in the numerator, plus in the denominator, then we have 1 plus 10A, 10B. That means both of these are exactly same, but the only difference is because of the sign. If it is positive, positive in the sign. If it is negative, negative in the sign. If it is positive, it will be negative in the cos. If it is negative, it will be positive in the cos. If it is positive in the 10, it will be positive in the numerator, negative in the denominator. If it is negative, negative in the numerator and positive in the denominator. Okay, so up till now, what we have done is AS identities, your O-level identities which are linked. We started off with normal A2 identities that are 1 upon sine theta is cosec theta, 1 upon cos theta is sec theta, cot theta is 1 upon tan theta, which is sine theta upon cos theta. Reciprocal, it will become cos upon sine. 1 plus cot square theta is equal to cosec square theta. 1 plus tan square theta is equal to sec square theta. We know that sine A plus B is sine A cos B plus cos A sine B. Sine A minus B is sine A cos B minus cos A sine B. Cos A plus B will be cos A cos B minus sine A sine B. Cos A minus B will be cos A cos B plus sine A sine B. Tan A plus B will be tan A plus tan B upon 1 minus tan A tan B. Tan A minus B will be tan A minus tan B upon 1 plus tan A tan B. Now we will be working on our double angle identity. Now, what I do is I try to link it with compound angle identities to make sure that you know the concept behind these identities as well. Now, let's say that we know we have sine 2a. We have sine 2a. Now, for sine 2a, what we need to understand is this sine 2a means sine a plus a. It's just that the normal identity which we used to have is sine a plus b. So in place of b, we have a. And the normal identity which used to be was sine a, and we used to be what? Cos b plus we used to have cos A sine B. So instead of this B, we'll be writing down A only. So if we just write down the proper identity, this should be written as sine A cos A plus cos A sine A. Now this thing will be sine A, cos A, cos A. So we can write this thing as 2 sine A, cos A. So that means that your sine 2A can be written as 2 sine A, cos A. Sine 2A can be written as 2 sine A, cos A. Similarly, if I say that we have cos 2A. Now, cos 2A is basically in form of A plus A, which obviously is substituted with B. B used to be there, it's now A. So if we just remember or just revise to the form, it used to be cos A, cos B minus sine A, sine B, because this plus used to change the sign and obviously we used to have B. But since now we have A and A, so instead of this B, we'll write down what? A, because of 2A. So considering this, what we can do is we can write down cos A cos A minus sine A, which means this will be cos square A minus sine square A. Now, one thing we know is that cos 2A can be written as cos square A minus sine square A. Now, this is your identity for cos 2A. Considering the same thing, let's say we have cos 2A identical to what? Cos square A minus sine square A. And what we remember now is that this cos square A was known as 1 minus sine square A. This cos square A was known as what? Sine square A, because that was your AS identity. So if we just substitute this with 1 minus sine square A, 1 minus sine square A, minus sine square A is already there because this cos square A is substituted with 1 minus sine square A, which is this, and minus sine square A is already here. So what we do is we write down this thing as 1 minus 2 sine square A. So now what we know is this particular value, cos 2A can be written as 1 minus 2 sine square A as well. So that means cos 2A can be written as cos square A minus sine square A, and cos 2A can also be written as 1 minus 2 sine square A. Similarly, here's another thing. Let's say, since we are working on cos 2A, and we knew that cos 2A was cos square A minus sine square A. Now, since we have known the identity of AS, sine square A is what? 1 minus cos square A. Sine square A is 1 minus cos square A. Now, so in this place, if I say, we can easily substitute 1 minus cos square A. So if we just substitute this in place of cos square A minus, and minus is already there, but this should be 1 minus cos square A. So cos square A minus 1 plus cos square A. So this should be 2 cos square A minus 1. So, which clearly means that cos 2A can also be written as 2 cos square A minus 1. So the three basic identities of cos 2A is, now that means cos 2A can be written as cos square A minus sine square A. Cos 2A can also be written as 1 minus 2 sine square A, and cos 2A can also be written as 2 cos square A minus 1. Now, according to the question, we will decide what identity to be used. If it's the identity is in sine, then we will apply this. If the identity is in the cos, we'll apply this. If the identity is showing in cos square A minus sine square A, then we will apply this. So that is up to the observation skills that you will have during the attempt of the question, that what identity to be used in your A2 question for cos 2A. With respect to this, we also know that since we have cos 2A, we can also have the identity of tan 2A, which means this should be written as tan A plus A. Similarly, the normal identity for this was tan A plus tan B upon 1 minus tan A tan B. But instead of B, now we'll be writing down A because of this 2A procedure, that obviously we'll be writing down A instead of B. So just writing down the identity, this should be tan A plus tan A 1 minus tan A tan A, which will be 2 tan A upon 1 minus tan square A. So that means double angle identities that we normally see or we normally know are basically linked with compound angle identities, but eventually you should be knowing that sine 2A can be written as 2 sine A cos A. cos 2a can be written as cos square a minus sin square a. Cos 2a when changed can also be written as 1 minus 2 sin square a. Cos 2a can be written as 2 cos square a minus 1, which I wrote here for three identities. And tan 2a can be written as 2 tan a upon 1 minus tan square a. So these are basically your three different double angle identities that can be written as. But remember that cos 2a can have three different identical, that is cos square a minus sin square a, 2 cos square a minus 1, 1 minus 2 sin square a.